So welcome everybody to this latest video on 162 Maths. In this video we'll be going over how to find the lowest common multiple LCM and how to find the highest common factor, the HCF. So let's get started on the lowest common multiple, which is abbreviated as LCM. Now the lowest common multiple of two or more numbers is just that. It is the lowest common number that appears in their multiplication tables. So for example, the lowest common multiple of 8 and 12 is 24, because if we look at the numbers in the 8 times table and the 12 times table, as you can see from this list, that you should notice that the smallest number that appears in both the times tables is 24. So therefore the LCM of 8 and 12 is 24. So let's have a look at an example question. So here let's find the lowest common multiple of three numbers. Now I would always recommend that you start with the largest of the numbers. So here I'm going to write 10, and all I'm going to do is I'm just going to write down the first couple of multiplications of 10. So the first common multiple, so 10, 20, 30, 40, 50, and let's say 60. Now typically if you multiplied all the numbers that you want to work out the lowest common multiple, so if I did 3 times 5 times 10, then that would give me 150. So that would be a common multiple, but is it the smallest? And that's what I'm looking for. So when I'm writing out the multiplications of, or the multiples of each of the numbers, I don't need to go as far as a number that's where you multiply the common multiples together. So here I wouldn't need to go to any number that goes beyond 150. So then if I then moved on to the next smallest, biggest, which is 5, so then just do 5, 10, so 10 appears in both of those, then 15, 20, 25, 30, 35, 40. So basically any number that ends in a 5 or a 0 is going to be in one of these, a multiple of 5, and any number that ends in a 0 is going to be a multiple of 10. So then move on to 3. So again, all I'm looking for, I'm going to stop whenever I finish on a number that either ends in a 0 or ends in a 5. So I've got 3, 6, 9, 15. So 15 appears in both 3 and 5. So the lowest common multiple of 3 and 5 would be 15. But because it doesn't feature in the 10 times table, I have to then carry on. So 18, 21, 24, 27, and 30. Now, does 30 appear in all of them? Yes, it does. So therefore, the lowest common multiple of 3, 5, and 10 is going to be 30. Now in an exam, if you are familiar with your 3 and your 5 and your 10 times table, which you should, then there'll be no surprise that you could do these types of questions in your head and just go to the answer straight away. But I would definitely, when approached with this question, if you're going to use this method to work out the LCM, is definitely write down at least 3 or 4, 5 terms that your multiples that you're working with. Try not to just end with 1 or 2. You'll get marks in terms of method if your answer is correct. And obviously if your answer is wrong, then you would still get some method marks that way. So then let's now have a look at the highest common factor. Now again, this is exactly what it says in the tin. This is the biggest common number that divides into each of the numbers, leaving no remainder. So here the highest common factor of 24 and 18 is going to be 6. Now although we can divide both 24 and 18 by 1, 2, 3 and 6, 6 is the biggest number from the list, so that's why it's labelled as the HCF. Now one way of finding the highest common factor of a set of numbers is to write down each of the numbers as a product of their primes, and again there's another video that covers how to do this. And what you then want to do is, without using indices or powers to simplify, multiply the common primes from one number together to give you the HCF. So one way of writing the POTP, or the product of their primes, is by drawing a factor tree for each number. So for example, if I had 120 and 300, so if I did 120, and all I'm going to do is do a factor tree for this, and again your factor trees may be different, but the circled numbers should always be the same. So here I've got 5 and 4 and 2 and 2, so that's that one completed. Then if I do one for 300, I've got 3 and 100, 10 and 10, and I've got 5 and 2, 5 and 2. So from this, what I've got is I've got 120 equals 2 times 2 times 2 times 3 times 5. And for 300, I've got 2 times 2 times 3 times 5 times 5. Now from this, what I can then do is circle which numbers appear in both this. So 2 is on both. I've got another 2 that appears in both. I've got a 3 that appears in both, and I've got a 5 that appears in both. Then if I take one line, so let's just ignore 300, so let me just put a little line through there. And if I take the circled numbers from one of the lines, then that means that the HCF is going to be 2 times 2 times 3 times 5, and that's going to be 4 times 15, which is 60. So the highest common factor of 120 and 300 is 60. Now another way of working out the lowest common multiple and the highest common factor is to use a Venn diagram. Now, unfortunately, by using a Venn diagram, you're not going to get away with not having to write each number as a product of their primes. That is going to be essential for you to do. Now, if this question comes up on a calculator paper and you've got a newer Casio calculator, then your Casio calculator has got a feature which allows you to convert numbers as a product of their primes without having to draw a factor tree. Now, on the Casio calculator, and if your calculator does do this, all you need to do is enter the number, press equals, then press shift, and then what you should have is just next to the negative button, which allows you to write numbers as a negative button, so just underneath the square root button, there should be a button that looks like this, and above it should say fact. Now if you follow these 4 steps, then what will happen is that it will then allow you to convert each of the numbers as a product of their primes. So to use a Venn diagram to work out the lowest common multiple and the highest common factor of 2 numbers, then the first thing you want to do is to convert each number into a product of their primes. Now you can do this by either using a factor tree if it's on a non-calculator paper, or by using your calculator if it's on a calculator paper and you've got that feature. But basically what you should have is that 520 equals 2 times 2 times 2 times 5 times 13. And note how I'm not using indices to simplify it. Then if I do the same for 60, then what I should have is writing that as a product of their primes. I should have, well actually let me use blue. I get 60 equals 2 times 2 times 3 times 5. Now the next step, what I then need to do, step 2, is then draw and complete the Venn diagram. So what I'm going to do is I'm going to have 520 as one of the circles and 60 as the other circle. So as you would expect to complete a Venn diagram using this sort of numbers that we're dealing with, I'm going to have numbers that appear in both of the 2 product of their primes in the middle, numbers that are exclusive to 520 in this section here, and numbers that are exclusive to 60 in this section here. And I should have no numbers that are outside the 2 circles. So let me just get rid of those 2 lines here. So numbers that appear in both, so I've got a 2 and a 2, another 2 and a 2. I haven't got a 3, but I have got a 5. So then the middle numbers are therefore going to be 2, 2 and 5. Numbers that are exclusive to 520 are another 2 and 13, and numbers that are exclusive to 60 is a 3. Now for this, once you've completed your Venn diagram and you're generally happy, and again you can check by multiplying all the numbers in the blue circle and it should multiply to give you 60, and if I multiply all the numbers in the red circle it should end up to give me 520. Now for the highest common factor, then what you need to do is basically multiply the numbers in, and again if I just do a little sketch of this, in the middle, so the bit that's in both, so basically it's the middle bit. So here my HCF is going to be just the numbers that are in the middle. So it's going to be 2 times 2 times 5, which gives me an answer of 20. Now for the LCM, and all you need to do here is basically multiply all the numbers that you can see. So here the LCM is going to be 2 times 2 times 2 times 3 times 5 times 13. And again, just I've got 1, 2, 3, 4, 5, 6, and I should have 6 numbers, which I've got. So if I multiply all those numbers together, I get 2 times 2 times 2 times 3 times 5 times 13, and the lowest common multiple is going to be 1560. And you might find that a much easier way of doing that rather than writing all the numbers times tables out. So let's have a look at a worded problem where lowest common multiple comes in handy. So this question says that 2 buses both leave a bus stop at 8:10. If bus A takes 35 minutes to complete its route and bus B takes 40 minutes to complete its route, what is the earliest time both buses will be back at the bus station at the same time? So here, what we need to do is we need to find the lowest common multiple of 35 and 40. So again, you're looking for the smallest number that appears in both the 35 times table and the 40 times table. So you can either write down those numbers. So I've got 40, 80, 120, 160, 200, 240, 280, 320, etc. And then 35, I've got 35, 70, 105, 140, 175, and then I've got 210, and then 245, and 280. So I can see straight away that 280 is there. Now another alternative I could do is, again, if I write 35 as a product of its prime, so I've got 5 times 7, and then 40 is going to be 2 times 2 times 2 times 5. So if I draw my Venn diagram, I've got 5 that appears in both. So this is a 40, this is 35. I've got 7 and I've got 2, 2, 2 there. So my LCM is going to be 7 times 5 times 2 times 2 times 2, which again is going to give me 280. So that means then that the buses will meet again after 280 minutes. Now what I need to do is I need to convert 280 minutes into hours and minutes. So 280 minutes is basically, well, 1 hour is 60 minutes. So it's going to be 60, 120, 180, 240. So basically it's going to be 4 hours and 40 minutes. So from this, what I've then got to do is I've got to then add this time to 8:10. So 8:10 plus 4 hours and 40 minutes is therefore going to be at 12:50 p.m. And there will be the time where those two buses next meet at the bus station. So then now let's have a look at our next question. So this question here, it says a Fate is selling hot dogs. Each hot dog comes with a bun, a sausage and a napkin. If sausages come in packs of 6, buns comes in packs of 4, and napkins come in packs of 10, what is the smallest amount of hot dogs that can be made so there is no wastage, and how many packs of each item would you need to buy? So for this, what we need to do first is find the lowest common multiple of 4, 6 and 10. Now from this, I'm looking for the smallest number that appears both the 4 times table, the 6 times table and the 10 times table. So from this, I've got, well, the lowest common multiple is going to be, it's actually going to be 60. So here the LCM of 4, 6 and 10 is going to be 60. And again, I've got 10, and that if I write down the first 10 times table, so 10, 30, 40, 50, 60, and then 6 times table, 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60, and then the 4 times table, again I can just go all the way, but I do know it's 60, so 60 appears in both. So I'm going to make 60 hot dogs. Now, to make 60 hot dogs, how much of each packs do I need? Well, if sausages comes in packs of 6, then I'm going to need to know 60 divided by 6, which equals 10. So I'm going to need 10 packs of sausages. For the buns, I'm going to do 60 divided by the pack size, which is 4, and that's 15. And then finally, for the napkins, well, that's going to be 60 divided by 10, which is 6. So in terms of how many will I need? Well, I'm going to need 10 packs of sausages. I'm going to need 15 packs of buns. And I'm going to need 6 packs of napkins. So now let's have a look at an exam question that involves algebra. Now this question came up recently in a GCSE paper. And as you can see, it's not worth many marks, but it is multiple choice. So the first question says, what is the highest common factor of 4x squared, y, and 8x? Now the highest common factor for this is basically, well, looking at the numbers of 4 and 8, which is the highest common factor of 4 and 8? Well, that's going to be 4. Now we're looking for numbers that divide into these. So what you're looking for here is, so for the highest common factor, you're looking for the lowest power of letter. So looking at the x's, the lowest power of x I've got is a single x, and the lowest power of y I've got is a single y. So the answer then is going to be 4xy. Now for the lowest common multiple, what we're looking for here is we're looking for the biggest number that appears, or the smallest number that appears in the 4 and the 8 times table, which is going to be 8. Now when you're looking at algebra, what you're looking for is you're looking for the highest power of letter for the lowest common multiple. So it's kind of like the opposite. So here, looking at the x's, the highest power of x I've got is x squared. And looking at the y's, the highest power of y I've got is y cubed. So I'm looking for 8x squared, y cubed, which is our third option. Now, hopefully that's given you some idea on how to commonly find the highest common factor and the lowest common multiple, but it's really important, I must stress this, is to make sure you know the difference between the two. A common error that people make when working these two calculations out is they often get wrong by thinking of the other one. So make sure that you recognize that the highest common factor is the biggest number that appears that you can divide both numbers by, and the lowest common multiple is the smallest number that appears in their times table. And then when you're dealing with algebra, it's the opposite. So with letters, for the highest common factor, you're looking for the lowest power of letter, and for the highest common multiple with algebra, you're looking for the highest power of letter.